In this video, we discuss something known as Descartes' rule of signs. This is actually a rule that allows us to determine the potential number of positive or negative real zeros. Before we can get into Descartes' actual rule of signs, we need to introduce a new idea. And so we say let f be a polynomial. The polynomial needs to be written in descending exponents from the largest down to the smallest. Then we introduce the thing called the variation of the function. Variation, or var f, is the number of sign changes in the coefficients of f as we go from left to right, or from highest down to lowest. And this is known as the number of variations. So as an example, if we had this polynomial, f of x equals x cubed minus 5x squared plus 8x plus 2, written from highest to lowest, we look as the signs of the coefficients switch from positive to negative or negative to positive, and we just count those things. So in this case, we see that there are two sign changes in the coefficients, so we would say that the variation of f of x is 2. Pretty easy idea, but it's essential to this Descartes' rule of signs that we're going to state in a moment. Consider a second example. Here we have a fourth degree polynomial, and again we just look for the changes in the signs of the coefficients. This time we have 3 sign changes, so the variation of, sorry, I should have said g of x, not f of x, is 3. And so that's the idea of variation. And so now we're ready to state Descartes' rule of signs. So there's two parts to Descartes' rule of signs. First, again, we're talking about polynomials. Turns out the number of positive real zeros of f is equal to the number of variations in sign, or less than that number by an even number. We're going to come up with a result in the next section that will kind of explain why it has to get down by even numbers. But if you remember in the quadratic formula when you had imaginary or complex solutions, because the square root was negative, well, there was a plus or minus. So they always came in pairs, and that's really why it's going down by an even number. We're going to talk about that a little bit more fully later on. The second part talks about the number of negative real zeros. And to look at that, we consider the variations in sign, not of f of x, but f of negative x. We go to the function, replace all the x's with negative x, and simplify, and then count the number of times the sign changes occur. Okay, so that's Descartes' rule of signs. Let's see it in action. So consider the polynomial f of x equals x cubed minus 5x squared plus 6x plus 3. Okay. First, let's count the variations in f. And we can see here that f sign changes, the coefficients change twice. So that means f has 2 variations in sign. So the number of positive real zeros is either going to be 2 or less than 2 by an even number. So you just keep going down by 2 till you can't go down any further. So there's either going to be 2 or 0 positive real zeros. And then we evaluate f of negative x. So this time I'm going to actually write it out. Negative x cubed minus 5 times negative x squared plus 6 times negative x plus 3. But you can actually speed this up a little bit by realizing that when you plug in negative x, the only ones that are going to change are the odd powers of x. The even powers, when they get evaluated to the even exponent, the even ones, when negative x gets evaluated to the even exponent, are just going to be the same. So basically this would become negative x cubed minus 5x squared minus 6x plus 3. And then you count the variations. And so we only have one variation in f of negative x. So the number of negative real zeros would be that number or less than it by an even number. Well, if you go less than that by an even number, you'd have negative 1. So negative 1 is not possible. So what this tells us is we guarantee that there's at least one real zero in this polynomial. At least one negative, and there may be two positive ones. If we look at the graph of the function, we can see that in this particular graph there's actually only the one negative one. It never crosses in the real on the real side. So let's move on to a second example. Again, using Descartes' role signs to figure out the potential number of real zeros. So again, we take the number of variations in f of x, and then we compute f of negative x. Again, remember, only the odd terms are going to change. So this time there's only one variation in the odd one, or f of negative x. So we know that positive real zeros is either going to be 3, the number of variations, or less than it by an even number. Same thing with the negative. It's going to be the number of variations or less than it by an even number. So this time you see we're guaranteed of at least one negative and at least one positive. There may be as many as 3 positive roots. If we actually look at the graph, we see that we end up with just the one negative and the one positive. It just doesn't stretch up far enough to get the other 2 positive roots. Okay, so that's Descartes' role signs, and it's used to give us an idea of how many times the function will cross the x-axis on the positive or negative side.